Okay, good morning class. So today we're looking at Euclidean geometry. We're looking at examples 4, exercise 4. Okay, at this point we have just proven the theorem, the similarity theorem. Okay, so the proof of this theorem can be found in the description box below. Okay. So now today we will be looking at example. Let me make a copy of this. We're looking at example 8. Example 8 is on page 261. And example 8 is for exercise 4 on page 263. Okay. So we are told that in triangle PST, in triangle PST, this is the larger triangle here, we are told that RQ is perpendicular to PT. So RQ is perpendicular to PT, so they're referring to that one thing. Not so? And we are told that TS, which is this line, is perpendicular to that line. Okay. So the question says, the first question says, you are required to prove that triangle PRQ, this triangle here, is similar to triangle PST. Okay. So when they ask you to prove similarity, we either prove that the two triangles are equiangular, which means to say all the angles are equal, or we prove that the sides are in proportion. That's one of two ways of proving similarity. When it comes to congruency, how do you prove congruency? 4 cases. Side, 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 angle, side, right angle, hypotenuse, side, and angle, angle, side. However, when you use side, angle, side, it must be the included angle. Okay? So we're dealing with similarity here. As you can see, we don't have any lengths given here. Okay? So of course we're going to prove that the angles are equal. They're equiangular. Okay, you all understand? So how do we start off similarity? Same as we start congruency. We name the triangles. In triangle PRQ and triangle PST. Please do not write in triangle PRQ is similar to triangle. No. We need to prove that fact. Okay. So what can we say? Remember this is highlight again. That is the one triangle and this is the other triangle. So of the two triangles, what do we know already? We know that angle P is a common angle. Sorry? PRQ. Sorry? So what do we know from this? We know that angle P is common. What else do we know? R1 is 90 degrees and PST is 90 degrees. So if two angles are equal, automatically that has to be equal to that angle. Why? Say for instance this is 40, then what's the size of this angle? 50, not so. And if this is 40 and this is 90, then this has to be 50. So if two angles are equal in a triangle, in two triangles, then the third one has to be equal. You guys understand? So most of the time when we prove similarity, you're just going to prove two angles are equal. And then you can conclude the third one is equal. Okay, you guys understand that? So, let's go. What can we say first? We say that angle P is your common angle. Later on you will have a common side as well. Okay? You can't just say common. Say common angle or common side. Okay? Then we know that R1 is 90. Why is R1 90? Because the angles on a straight line, or we can say that QR is perpendicular to PT. So R1 is equal to angle S, which is equal to 90 degrees. Okay? It was given 90, not so. And then on the third case, what can we say? We can say that Q2 has to be equal to angle T. Why? It's the third angle of triangle. The third angle of a triangle. Okay. So we can conclude, therefore triangle PRQ is similar to triangle, and we check. You see PRQ, P was the common angle, so it must be P. Then I went to R, which is the 90, so it's PS. What's on top? T. Is that the order? Most of the time that order is in the right order. Okay? And the reason here is angle, angle, angle. So that is angle, angle, angle. Okay? Is there any confusion? Alright. So if you are given a proof like this, we have to prove the two triangles are similar. What will always follow this is a distance question. Okay? They will ask you a distance question. And if you look at B, that's exactly what they asked you. B, they want you to prove that RQ is to PQ as ST is to PT. Okay, but I normally work with the fractions. So in other words, to me they're asking me to prove that RQ over PQ is equal to ST over PT. But remember, it's going to come from here. So we say that PR over PS. That's why order is important here. Okay, PR over PS is equal to RQ over ST equals the first and the last PQ over PT. And what's the reason here? Why can I conclude this? Because triangle PRQ is similar to triangle PST. That's a reason. Okay. So what do they want? They want RQ. So let's see, they want the RQ. Do I have RQ? Yes. They want PQ. Yes. ST. Yes. And PT. Not so people. So what can I say? Therefore, using this now, no? Therefore, RQ, PQ. You see, this is according to my ratio now. I have RQ is to ST as PQ is to TB. But that's not what they want there. Not so. So what do? I cross multiply. I interchange those two. Remember when we did the ratios, we could have interchanged that. Not so. So that is what I'm doing here. I'm interchanging that. I'm going to now say that RQ over PQ is equal to ST over TP. Okay. And this in turn is RQ is to PQ as ST is to P. Okay. Any confusion there? do the next one here on the side. Okay, this is from A. So let's look at C. C, they want you to work with PR times PT. Okay? So let's go with this ratio again. We know that PR over PS. PR over PS. PR over PS is equal to RQ over ST equals PQ over PS. Why? Because triangle PT. Thank you. Because triangle PRQ is similar to triangle, it's not, well, it's congruent, it's similar to triangle PST. Okay. So let's see what they want. They want PR. Let's see. They want PR. So it's PR and PT. And PQ and PS. Can you see that, people? But in actual fact, it's PR times PT. And yes, we can cross multiply, not so. So let's go. We cross multiply those two. Then I'll get PR times PT is equal to PQ times PS. Okay. I think it's fairly simple. No? So any questions? Alright, let's look at the next example. Example 9. Sorry about this now. This is example 9. Example 9 is on page 262. Okay. Example 9, we are told that A, B, C, and D are concyclic points. What does that mean? What does concyclic mean? Circle is drawn through those points. Not so. Then we are told that DOC and AOD are chords. BD and AC are joined. Prove that. Okay, did I tell us that O is the center of the circle? No. So can I assume that? No. Okay. I don't think we're going to need that fact, but I'm just saying now to note that. Okay. So, the first question says you must prove that triangle AOC is similar to triangle DOB. Where do we start? In triangle AOC and triangle DOB. So AOC DOB. I think we're actually going to use that. They had to tell us that O is the center of the circle. Okay. We will need it. Or not? No. Okay, so to prove that the two triangles are similar, we need to prove that the angles are equal. Okay, so they're equiangular, the two triangles are equiangular. So what can we say first? Angle O1 is equal to O2. Why? Vertically opposite. Secondly, angle D is equal to angle A. Nice. Angle D is equal to angle A. Why? Angles in same segment. It is coming from arc BC. Okay. Why did I have to draw two arcs here? Because by drawing one arc means to say, if I draw one arc here, those angles are also equal. Okay. And then B, angle B is equal to angle C. Why? Third angle in triangle. Or you could have written angles in the same segment. People, is that enough to conclude similarity? Yes. So therefore triangle AOC is similar to triangle BOD. DOB. Why? Because angle, angle, angle. So what did I say? What normally follows a similarity question? A distance question. So here, as you can see, they are referring to distance. So we know that AO over DO is equal to OC over OB equal AC over DB. The reason here is that triangle AOC is similar to triangle DOB. What do they want? They want OB, OD, OC, OA. Can you see that, people? But is it in the right order they want it? They have OA at the bottom with OC on top. Can you see that? So OC and OD is in the right place. So that must interchange. You guys understand? So I can just interchange. Therefore, OB over DO is equal to OC over. They have just proven what they want. Okay. See any confusion? Not yet. Okay. Number 10. Example 10. Which page is example 10 on? 265. Okay. So what we've done so far was enough for exercise 4 on page 263. So I would like you guys to do the first 3 sums. There are 5 sums, I think, in that exercise, correct? So you're going to do the first 3 sums. We'll answer that on Monday. Okay, all 3 sums we'll answer on Monday. Okay? Sure.